Hey guys, this is video 3.2. In this video we're going to talk about how to figure out the molar mass of an element. Okay, this is something again that we will use. It's related to the mole, hence the term molar, right? Okay, that's where that comes from. So this is just the mass in grams of 1 mole of anything. So for elements, it's really easy. Okay, so for elements, the molar mass is equal to the atomic mass. So some of you have kind of said, oh, you know, a unit is grams per mole or whatever for it. That's what we're going to be talking about here. Okay, so we get this from the periodic table. So exactly as you see it. Now, to be honest, okay, you can round the masses, guys, to 2 decimal places. That is totally acceptable and fine. So if you're looking at answer keys of mine that I've made, your answers may be slightly off, but if they're really, really close, then you know you did it correctly. I've just rounded to 2 decimal places instead of going to 4 like it shows. So for example, 1 mole of carbon is 12 grams of carbon. All right, 12.01 if we're going to go to 2 moles. All right, so why don't you guys right now get your periodic tables out, and you guys figure out the molar mass of calcium and the molar mass of iron. All right, so when we take a look, the molar mass for calcium is 40.08. All right, pretty straightforward, pretty easy. Okay, and then if we look for iron, again, make sure you are looking at iron. All right, the hardest part about this is going to be finding the elements. Once you get familiar with them, it'll be so much easier. The molar mass of iron, if we round it to 2 decimal places, would be 55.85 grams per mole. Okay, and notice I keep saying that, right? The unit is going to be grams per mole, because if we take a look here at this conversion factor, now we've got moles and grams related. So a lot of times you will see it written like this: 55.85 grams per 1 mole. Okay, and that's just a definition piece of what molar mass is. So when we refer to mass of an element or mass of a compound, which we'll get to, it's grams per mole, because it's the grams in 1 mole of a substance. So how do we look at that? Well, that's 6.02 times 10 to the 23rd atoms of iron. So when I have Avogadro's number, 6.02 times 10 to the 23rd atoms of iron, it turns out that it is equal to 55.85 grams. Okay, so we have 2 conversion factors now. We have one for Avogadro's number, right, that we looked at in the last video, and now we have molar mass as well. All right, and notice, are these 2 able to link between each other? Absolutely, because in both of these conversion factors we have that same piece, which is mole. Okay, so since we have mole, we can now go from atoms to grams in a 2-step conversion process, and that's exactly what we're going to start looking at here a little bit. All right, so let's do a couple practice problems together. First one, all right, how many grams are in 2 moles of helium? So every problem, always start with what you're given. We have 2.0 moles of He. Set up our T-chart because we want to go from moles to grams. So grams of He will be over here. So when I try to set up my next conversion factor, mole is going to go on the bottom because we want it to cancel out. Grams of He will go on the top. So 1 mole, notice again, 1. The term mole, guys, is always going to get 1 because mole is always going to be our counting unit that's going to be smaller. Okay, so when we go from moles to grams or moles to atoms, those things will always be bigger. Moles should always be the smallest number that we have. And then when we look up helium, without rounding, just for the sake of this example, all right, that's what we would get. So our final answer, we would end up, if we have 2 moles of helium, we have, or that is equal to 8.00520 grams of helium. So if I have 8 grams of helium, I have 2 moles of helium. Okay? So, example number 2, how many moles are in this? This is a review from our last video. So I would encourage you guys to pause this and check and see where you're at. So we've got 3.01 times 10 to the 23rd atoms. So it's very important. Notice how I am writing my units every single time, guys. That's a very, very important technique to get in the habit of. Later in the year, we will be going from one substance to a different substance, okay? So it's very important that you get in the habit right now of writing down what substance we're looking at so that later on you're not scrambling, all right? So atoms of silver on the bottom. All right, 2 moles of silver on the top. 1 mole is 6.02 times 10 to the 23rd. So then there we go. When we do this, we get 0.500 moles of silver. Okay. Now, let's take a look at example number 3. It says, what is the mass? What's my unit for mass? That would be grams. What is the mass of 1.20 times 10 to the 8th atoms of copper? So notice now we're going from from atoms to mass. So this is going to be a very helpful tool. What I'm about to draw, I'm trying to find some space. I would encourage you guys to write this on your reference tables. Okay, so wherever you want to, whether it's on the bottom of the periodic table or on your formula sheet. Formula sheet's probably a good way to look at it. I want us to write the mole roadmap. Okay, so mole, guys, is the link between grams and atoms. All right, so over here on the left, we're going to have grams, which again is mass. And over here, we're going to have particles. Now, we had in the last video, we talked, there's a lot of different units that we could see for particles. Let me clear that up. Okay, the other terms that mean the same thing as particles would be atoms, ions, formula units, or molecules. Okay, they all mean the same thing. Remember, they just give us an idea as to what type of bonding or what type of substance we have, but they all refer to the same part on our roadmap here. Okay, so if I want to go from mass back to moles, I divide by the molar mass. Okay, that's what we were just talking about here in these last couple of problems. If I want to go from moles to particles, then I have to multiply by Avogadro's number. Okay, so we can then go from mass to moles to particles. Notice we can't just go right over here, mass, and jump directly to particles. That doesn't fly. We have to go to moles first. Okay, and that's going to be a common theme all year long, so remember that. Now, if I want to go the reverse, if I want to start over here at particles, like this problem is, then I've got to go from particles back to moles. Well, what's the opposite of multiplying? That would be division. So I'm going to divide by Avogadro's number, get me back to moles. Then I can, once I'm back at moles, then I can go do the opposite of dividing by molar mass. I can multiply by it to get to grams. All right, and that's exactly what we're going to do in this problem. We're starting at particles. We have to go back to moles first, then we can go to mass, to grams. So it's going to be a two-step problem. When you're at each end of the roadmap, it's going to be a two-step problem. So again, start by jotting down what you have to begin with. 1.20 times 10 to the 8th atoms of copper. And it's important, again, to write copper in there because that's going to guide us to our molar mass. So start by canceling out my units, atoms of Cu, moles of Cu. So 1 mole is 6.02 times 10 to the 23rd. So again, notice, I'm going to use a highlighter here. I'm over here, right? That's where I'm starting. So in order to get to where I want, I got to go to moles first. Then I can go over here to mass. Okay, so that's kind of guiding me in this. So atoms are gone. Moles is not the unit that I want to end up with. Mass is, so I got to do one more step. So moles of Cu on the bottom, grams of Cu on the top, 1 mole. And then where do I figure out the number of grams? I go to my periodic table. So 63.546 would give me the molar mass of copper. Now I just have to do the math. Remember, guys, wherever you see a T, it's multiplication. So I have two tops. I'm going to multiply 1.20 times 10 to the 8th times 1 times 63.546, and I'm going to divide by my bottoms. How you do that math is up to you, okay? But the answer should be 1.27 times 10 to the minus 14 grams of copper. Now you might be asking yourself, how do I know where to round to? Guys, look at sig figs. Go back to your original number. We had 3 significant figures here, so our final answer should have 3 significant figures as well. All right, I would encourage you guys, try this problem on your own. You have the mole roadmap. Pause the video and see how you do. All right, so I'm starting with 11.5 grams of boron. I want to get 2 moles of boron. So I'm going to kind of clean mine up here just to kind of, so I can kind of look at it here with this problem. All right, so if I look, I'm at grams. So I'm right here, and I want to just get to moles. So this one is just going to be a one-step problem. All right, so grams of boron on the bottom, moles on the top. 1 mole. I'm going to look up the molar mass, which is 10.81. Cross those out. Do my math. 1.06 moles of boron. And again, original number was 3 sig figs, so my final number should be 3 sig figs. All right, this last one, this is a 2-step problem like example number 3. Pause the video, try it, and see how you do. 8.0 times 10 to the 19th atoms of silver. Set up my T-chart. So again, I'm over here. I'm starting on the right in this problem. Oops. Okay, I'm starting over here on the right, and I need to go to mass. Well, the only way I can do that is a 2-step process. Okay, so let your units drive your math. Atoms on the bottom, moles on the top. Atoms are gone. 1 mole is 6.02 times 10 to the 23rd. Okay, now I got to do one more step to get to grams. Moles of silver on the bottom, grams of silver on the top. 1 mole, when I look it up, is 107.87 grams. So now I just have to do my math, and when I do that, I should get 0.014 grams of silver. Now, I know that's a lot, so ask questions if you're confused. You're going to get practice here after you watch the next video, and then it'll be a little bit mixed together. So take your time and make sure you practice and ask questions. I'll see you in the next video.